So here is the solution to problem number 12 on section 5.3. All right, so let's read. It says, an airplane is flying at a constant speed of 360 miles per hour and climbing at an angle of 45 degrees. At the moment the plane's altitude is 10,560 feet, it passes directly over an air traffic control tower on the ground. Find the rate at which the airplane's distance from the tower is changing 1 minute later. Neglect the height of the tower. All right, so we have this tower that is on the ground, and the airplane takes off from somewhere, and it is flying over the tower, right? It passes over the tower at 10,560 feet, which is 2 miles, right? So we can put 2 miles there. Now, this is a perpendicular distance to the ground. Then it continues to fly for another minute. And so the question is how far or how fast is the distance that the airplane is from the tower changing after 1 minute? That's the question. All right, so what is at play here? All right, obviously it's flying at a 45-degree angle, right? So that means that this distance would be 2 miles as well, right? Because of 45, 90 triangle. Okay, now we have D, which is the hypotenuse of another triangle here, which is, of course, has a right angle. So now we'll call this X because the horizontal distance of the plane is changing. Okay, and so there's a dx dt. Okay, now if we think about this, if we draw in this horizontal here, then that means that this is also a 45, 90 triangle up here. So that means this distance right here is also X, and this distance is 2. And so this overall distance is actually just X plus 2, which is nice because then we don't have a different variable to deal with. Now, you were told that the plane is flying at 360 miles per hour. So we have the distance that it traveled initially, call that A, and then the distance that it traveled after that, call that B. Okay? So now the distance that it is changing along this 45-degree angle is 360 miles per hour. So if we consider A plus B as a single distance, then the derivative or the rate of change of A plus B, so dA plus B dt, is actually just 360. All right, so now we have all of this stuff to deal with here. Okay, so the first thing that I want to do is I want to look at the big triangle that you see, the big right triangle. It is a 45, 90 triangle. So we can say that A plus B squared is equal to the horizontal distance here, which is X plus 2 squared, plus the vertical distance, which is actually also X plus 2 because this is a 45, 90 triangle. Okay. Now, what we can do here is we can relate A plus B and X together. Now, if I have the distance that X is, then I could figure out the distance that A plus B is. So how do I figure out what X is? All right, so to figure out what X is, okay, I look at this smaller triangle up here, okay? And what we realize is that B represents the distance that the plane has traveled in 1 minute. So remember, 1 minute is equal to 1/60th of an hour, right? And so if the plane is traveling at 360 miles per hour for 1/60th of an hour, so 360 times 360 miles per hour times 1/60th of an hour. The hours, of course, reduce, and you're left with 360 over 60, which is 6 miles. So that means the plane has traveled 6 miles. So B is 6 miles. So if I look at this small right triangle here, I can say that B squared is equal to X squared plus X squared. or b squared is equal to 2x squared. And we just figured out that b is 6 miles. So 6 squared is equal to 2x squared. All right, so 36 is equal to 2x squared, so I divide by 2. I get 18 is equal to x squared, and so x is equal to the square root of 18. Or we can say 3 root 2. So I can use the value of x being 3 root 2 to figure out what a plus b is. Okay? All right, so now I'm going to take the derivative here. All right, so the derivative of 2a plus b would be the derivative of a plus b squared is 2 times a plus b to the first times the derivative of a plus b, which is d a plus b dt, equals. Now, this thing already, if you put it together, was 2x plus 2 squared, and so its derivative would be 4 times x plus 2 to the first times the derivative of x with respect to t. All right, so now, going back, I know what b is. B is 6. What about a? Look at this small right triangle here. Okay, if this is 2 and this is 2, then I can say, so I'll do a little bit more work on the side, I can say that a squared is equal to 2 squared plus 2 squared, or 4 plus 4, so a squared is equal to 8, which means a is the square root of 8, or 2 root 2. All right, so now, in this problem, we plug in our known quantities. So 2 times 2 root 2 plus b, which is 6, times the derivative of a plus b dt, which we said earlier was 360, equals 4 times x plus 2. So x, we figured out here, was 3 root 2 plus 2 times dx dt. So now I can solve for dx dt. So dx dt is equal to, I take that thing divided by that. So 2 times 2 root 2 plus 6 times 360 divided by 4 times 3 root 2 plus 2, right? Now, if you do this calculation, we get 254.558. Now, that's great, but that's not what is asked for. What was asked for was the rate of change of d. So now I need to do another Pythagorean theorem problem. So now we take this right triangle here. So I'll highlight that with a different color so we can see it. We have this right triangle here. So we have d squared is equal to x squared plus x plus 2 squared. Okay, so now what do we want to do? Well, we need to take the derivative, of course, and plug in our known quantities and solve for d, dt. All right, but in order to do that, we need to know the value of d. So we're going to use this Pythagorean theorem here to find the value of d. So d squared is going to be equal to, d squared is equal to x squared, which from above was just 18, right? So x squared equals 18, plus x plus 2 squared. So now we need to use x, which was the square root of 18, or 3 root 2, right? So the square root of 18 plus 2 quantity squared. So that is d squared, or you could say that d is then the square root of all of that. So, of course, this one we could just do a calculation. If we do that, we're going to get that d is approximately 7.548. All right, so now we're going to need to use dx and dx dt in order to find the value of d dt. So let's take our original d equation and take the derivative. So the derivative of this, of d squared equals x squared plus x plus 2 quantity squared, all right, is going to be 2d dt equals 2x dx dt plus 2x plus 2 dx dt. And so now I just want to solve for d dt. So that means I'm just going to divide by 2d. All right. So d dt equals 2x, which we found in our earlier work, 3 root 2, times dx dt, which we found over here, which we just calculated to be 254.558, plus 2 times x plus 2. So, of course, we'll move it over a little bit. X was 3 root 2 plus 2 times dx dt, which we found over here to be 254.558, all divided by 2d. So d, which we calculated up here to be 7.548. Now, obviously, that is all numeric, and so then we would be able to just do a calculation to arrive at our final result. So the calculated value of d dt is 353.624. And depending on rounding, maybe that number will vary a little bit. All right. But the units, well, this is a distance that is changing. And so we would say that this is in miles per hour.